Okay, this is part 2 of lesson 7.3, double angle formulas. And this video is about how we can use double angle formulas. The first two examples are using double angle formulas to simplify an expression, and the second one is to evaluate or determine the value of a double angle. So let's start with our simplifying. Our first example here says express 6 sine x cos x as a single function. So to do that, we're going to use the double angle formula, or one of the double angle formulas. So I'm going to take a look here at our double angle formulas, and we want to find the formula which has the most resemblance to the expression we're given. We're given 6 sine x cos x, and we want to simplify it as a single function. Right now, we have two functions, sine x and cos x. We want to put them together as one function. So either sine, cos, tan, or any of the other trig functions. But we know double angle formulas for sine, cos, and tan, so hopefully there's one on here that'll help us. And the double angle formula for sine looks a lot like our expression. The only difference is that instead of 2, we have 6. So how can we manipulate that expression to make it look like 2 sine x cos x? Well, what we can do is we can factor a little bit. We could take a factor of 6 out so it looks like a 2. And that factor is 3. If we rewrite this as 3 times 2 sine x cos x, then we essentially have exactly the double angle formula. But instead of x's, we have thetas, but that's fine. It's just a variable. So now we can use the double angle formula. Instead of 2 sine x cos x, we could rewrite that as sine 2x. As sine 2x and 2 sine x cos x are equivalent expressions, and we know they're equivalent because we have an identity that says they are equivalent. Sine 2x equals sine 2 sine x cos x. That's taking two functions and condensing them into one function. And we can do something similar in our next example. Our next example asks us to express as a single function. And again, we have two functions. We have cos and sine. So we need to look at our identities and see if there is one that looks like this identity, and we do have one. The double angle formula for cosines in its first configuration says cos squared theta minus sine squared theta. And if we look, we have cos squared minus sine squared, and in this case our theta, or our angle, would just be this x over 4. So by patterning, that means that if we want to condense this into one function, cosine, we would write this as cos 2, and instead of theta, we would write x over 4. So here we go. We can condense this into cos 2 x over 4. And then we just have to do a little bit of math to simplify. 2 times x is 2x divided by 4. 2 over 4 is a half. So we've got cos of x over 2. So there's two examples of using the double angle formula to simplify an expression. Our next example is where we're going to use the double angle formula to evaluate. So here we go. If cos theta equals negative 2 over 3, where theta is an angle in quadrant 2, determine the value of cos 2 theta and sine 2 theta. Check your solution with example 2 on page 404. We're going to check our solutions right now because we're going to do it together. The first thing we're asked to determine is the value of cos 2 theta. Well, what is cos 2 theta? Well, according to the double angle formula, cos 2 theta is any of these. And if we look at the three configurations, the first one has both cos and sine, the second one just has cos, and the last one just has sine. What we know from the question is, well, we know what cos theta is. So we don't really have to do much work if we want to solve the double angle, or if we want to solve for the double angle, if we use the equation that just has cos in it. And that's the second equation. Yes, it's cos squared theta, but cos squared theta is just cos theta times cos theta. So we're just multiplying it or squaring it. So let's use this configuration, and I'll show you how you can find the double angle using this configuration. So we've got cos 2 theta is equivalent to 2 cos squared theta minus 1. Well, cos squared theta is just cos theta squared. Cos theta times cos theta. We know what cos theta is. It's negative 2 over 3. So this expression is just equivalent to 2 times negative 2 over 3 squared minus 1. Negative 2 over 3 squared is 4 over 9. 4 over 9 times 2 is 8 over 9. Minus 1, if we're subtracting fractions, we've got minus 9 over 9. Subtracting the numerators, we end up with negative 1 over 9. So cos 2 theta is just negative 1 over 9. If we want to solve for sine 2 theta, we only have one identity. It's this one. To use this identity, we need to know what sine theta and cos theta are. We only know what cos theta is, so we got to find what sine theta is. How do we find what sine theta is? Well, we actually have to graph it on the Cartesian plane. So here we go, let's graph. It says that theta is an angle in quadrant 2. So there's our angle. And if we use our information about cos, we can label this triangle. Cosine is x over r, or adjacent over hypotenuse. Adjacent, negative 2, makes sense because we're on the left arm, which is negative, and 3 for the radius, which is positive, makes sense. If we want to know what sine is, sine theta, we need y opposite over our hypotenuse. We don't know y. So if we want to find y, we have to use Pythagorean theorem. Y squared equals r squared minus x squared. That's just Pythagorean theorem. A squared equals c squared minus b squared. So let's plug in what we know. We know r squared is 3 squared. Subtract negative 2 squared is y squared. 3 squared is 9. Negative 2 squared is 4. 9 minus 4 is 5. If we want to solve for y, we square root. So y is just root 5. That makes sine root 5 over 3. Now that we know what sine theta is, I'm going to box my answer over here, we can find what sine 2 theta is. And we can do that by using the identity 2 sine theta cos theta, which is the double angle formula for sines. 2 is a number, sine theta is root 5 over 3, and cos theta is negative 2 over 3. And now if we multiply this across, 2 times root 5 times negative 2 is negative 4 root 5. And in the denominator, 1 times 3 is 9. So sine 2 theta is negative 4 times root 5 over 9. Those are two applications of the double angle formula. I hope you enjoyed, and I'll see you next time.